welcome to another physics class. And today our topic continue, that is time used in motion, which I promised the last video. Now, we are going to look at position, distance, and displacement. The first one there, position. Position. This one simply means the position of an object in space or plane is the point where the objects can be located with the frame of reference. That is the point in space or plane where an object can be located with the frames of reference. That's what I mean by position. And at the same time, we need to define what space and plane mean. Now, space is defined by 3 frames of reference. 3 frames of reference or 3-dimensional coordinate. That is S, Y, and Z. S, Y, and Z coordinate system. That's what I mean by space. That is when you have the 3-dimensional coordinate, which is S, Y, and Z coordinate system, then we use that one to define space. Plane is the geometrical figure defined by 2-dimensional coordinate or 2 frames of reference. That is S and Y coordinate. S and Y coordinate. That's plane. Plane involve 2-dimensional coordinate, that is S and Y coordinate, and Y space involve 3-dimensional coordinate. That is S, Y, and Z coordinate. Next is how to determine the position of an object using the S, Y, and Z system coordinate or S and Y coordinate. That is, as I said, under space involve 3 coordinates, while plane involve 2-dimensional coordinate. Now let's look at example. From this example 1, point A is located at 2,3 on the Earth surface. Sketch a graph to show the position of A. Solution to this one. Solution. Now, we have to sketch a graph to show the position of A. Now, the point at which A is 2, 3. Under this one now, let's now play. This one is on XY coordinate. So this one will be X, while this one will be Y. Now, to show it on a graph, just draw your X, Y, and S coordinate. Now, according to this figure, X is positive, Y is positive. Just to show a sketch, you can put this one as 1, 2 for Y. Y is 3. Y, let's say this is 1, 2, 3. 1, 2, 3. To show this one now, X is 2, Y is 3. Now trace it. Where the two lines intersect on 3 for Y and on 2 for Y. So this is the position of that point A, that is 2, 3. That's the correct answer to that one. Now, look at this example now. It's just the opposite of this one. The graph for this one has been sketched there. Then you need to state the position of point Q. Now, if you look at it, for X, we have 3. For Y, it falls on the negative Y axis, we have -5. So if you now trace it, this point Q, trace it, this point Q. So the position of point Q now, position of answer, position of Q now will be, write S first, 3, -5. That's position of point Q. That's the answer to that one. Now, let's now move to distance. When we get to example under distance, we will have more example under position. Now, distance is the separation. Distance is the separation between two points. That is the separation between 2 points. That's the definition of distance. Other facts about distance. Distance is a scalar quantity. Scalar quantity. What mean by that is that it has only magnitude without a specified direction. So distance is a scalar quantity. Already we know that distance is measured the unit. The unit is meter. Meter. M. And to measure horizontal distance, which we have done before, the best instrument to measure horizontal distance is odometer. Don't forget our former lesson. And if it is vertical distance, which is height, we use altimeter. We discussed that one from our former lesson. Now, that's distance. Now, the next thing is distance between 2 points. 2 points. Distance between 2 points. Now, to calculate distance between 2 points, the magnitude of distance between 2 points of distance between 2 points is given as distance S is equal to square root of S2 minus S1 to square plus Y2 minus Y1 to square. That is when we use two coordinates. When you use two coordinate system, or if you use this one is for two coordinate system. If it is three coordinate system, we are going to have distance between 2 points as S2 minus S1 square plus Y2 minus Y1 square plus Z2 minus Z1 square. This one for three coordinate system. Let's now look at the first example. 2 points A and B. A at this position, B at this point are on plane. The question says sketch a graph to show the position of points A and B. 2. Find the distance between A and B. If you look at this one now, the first question is under position. Let's now look at it. According to A is located at 2, 3. Call this one S and Y. But since this one involves 2 points now, that is A and B, call this one S1, Y1. For B, B is located at -5, 3. Call this one S2 and Y2. Now to locate their position, just draw your Y and S axis. This is Y, this is S. Let's first locate point A. For S is positive, which is 2. You need to sketch 1, 2. Can be more than that, but because of the space. Then for Y is 3. That is 1, 2, 3, 4. 1, 2, 3, 4. So for S is 2, trace it out. For Y is 3, trace it. So it means the point of intersection between S and Y is where the point A is being located. So this is point A now, 2, 3. Now to locate B, S on B side is negative. So show it. -1, -2, -3, -4, -5, -1, -2, -3, -4, -5. You can extend it depending on the question given to you. For Y, Y also is positive 3. So you can now say that trace it, because Y is positive, trace it up on -5, then trace it from 3 for Y. So any point, this is the point of intersection between the two S and Y. So here we are going to have our point B. which is minus 5 for x and 3 for y. Thus, we've located the 2 points now. The second question says we should find the distance between points. This is answer to A now. B now. Then we go back to our formula because this is two-dimensional coordinate. So we are going to use the distance between A and B now will be equal to square root of s2 minus s1 square plus y2 minus y1 square. So already we know s2, we know s1. Let's put the value now. This one will now give us our s2 is minus 5. Our s1 is 2 minus 2 square plus our y2 is 3. Our y1 is 3. That is minus 3 all into square. Now, let's do the subtraction now. This one will now give us minus 5 minus 2. That will be minus 7 square plus that will be 0 square. So this one will now give us 7 minus 7 square will give us square root of 14. That's 49. 7 times 7. Then from there, we can now say that the final answer will be equal to 7. That's the distance between the 2 points A and B. Now, let's take this one as the example 2. A line x, y is specified by the coordinate x 2, 4 and y 6, 10. The first question is sketch a graph to show the position of x and y. And the number 2 question, determine the length of the line in centimeter. The first A question deal with position. So let's look at the position for x. For x, the position of x is 2, 4. And the position of y is 6, 10. We are going to calculate the distance. Let's put our s1, y1, s2, y2. Now, to calculate sketch the diagram now, as usual. This is our y and x. Let's first locate the position of x. X is 2, 4. 1, 2, 3. 1, 2, 3. For y is 4. 1, 2, 3, 4. So that one will now give us 1, 2, 3, 4. Now, to locate this one now, 2, trace it up, 4, trace it. Where the two lines intersect is the position of x, 2, 4. Now for y now, let's extend this one. 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. Because y2 is 10, s2 is 6. So we are still going to extend this one too. 4, 5, 6, 7. Both are positive. So we are going to have 4, 5, 6, 7. Now for y now, trace it up. That is for this y. The x2 is 6. Trace it up. Y2 is 10. Trace it where the two lines intersect. This position of y now. Y 6, 10. That is answer to question 1. Now to answer question B now. B, our coordinates also is two-dimensional. So you can now say distance s, y, according to the question, to determine the length s, y will be equal to square root of x2 minus s1 square plus y2 minus y1 square. It has been specified. So our x2, according to what we have from the board, is 6. Sorry. Our s1 is 2 minus 2 all to square. Our y2 is 10 minus y1. That's 4 square. So this one will now give us square root of 4 square plus 6 square. So this one will now give us this 16 plus 36. And 36 plus 16. Now, 16 plus 36 will give us 52. And finally, the length sy now, which the scale will be 7.2. According to the question, it should be in centimeter. That's the answer. Now, let's take this one as example 3. The position of an ant A and a spider S in a room are A 2, 3, 5 and S 6, 0, 8. If Q is a point in the room represented by Q 1, 0, 2, then the first question, determine the distance between the point Q and the ant. 2, distance between the point Q and the spider, and the distance between the spider, the ant and the spider. Let's list out the parameter given in the question. Now, from the question given for Q, these are the point position. For A, these are the position, and this one is 3 coordinate system, that is involve x, y, z. So for S, which is the spider, x, y, z also. The fourth question says to calculate the distance between distance between Q, A. Then let's use our formula. That is S2 minus S1 square plus Y2 minus Y1 square plus Z2 minus Z1 all into square. According to the equation, we want to calculate for the point Q and ant for S2, which is for ant. That is 2. That will be square root of 2 for S1 minus 1 square plus Y2 3 Y1 minus 0 square Z2, that is 5 minus Z1 minus 2 all into square. So this one will now give us 1 square plus 3 square plus 3 square. So it will now give us 1 plus 9 plus 9. This one will now give us 19. Answer for this one is 4.4. That is distance between the point Q and the hand. For Q and S, the formula remains the same, but the only difference is the figure. Now let's take Q and S. This is Q, this is S. So if we take this one as S2, that would be 6 minus 1 all into square plus for Y 0, 0, 0 minus 0 all into square. Then for Z, 8 minus 2, 8 minus 2 square. So this one will give us 5 square plus 0 square plus 6 square. So this one will now give us 25 plus 36. This is square root of 61, and the answer will be 7.8. That's the distance between Q and S. For the distance between the ant and the spider, the formula remains the same, but the only thing that's different is the value. Now, for this one, the S2, which is AS, this is the S, that's 6 minus 2 square plus our Y here is 0 minus 3, and for Z square, that will be 8 minus 5. So this one will now give us 4 square plus minus 3 square plus 3 square. So this one we got 16 plus 9 plus 9. Now this one we go for 16 plus 18. That will be 34. And the square root of 34 is 5.8. 5.8. That's the distance between the the ant and the spider. I think this is a convenient point to stop for today. In our next video, we'll continue on displacement. And as I said earlier, if you are new to this channel, please try to share, like, and subscribe. So when I upload the next video, you'll be able to see the notification.